right? So we're good to start with the session now. Let me share my screen. In our last session, we have manually done the setup in our local system. Like we have installed the VS Code, and then we have created manifest project template, and accordingly we have done some development. So it's like just for our testing, we have created a class like foo.cls, and then accordingly the meta XML, right? And once this is done, we have deployed our changes to Salesforce org. The same way, we have created some class here, some piece of code, and then we have retrieved it from our VS Code. And we have done this practically, right? So we have also uploaded all the videos. I believe you guys have visited it and done some hands-on experience. Okay. Today I will cover all this part that we did manually with use of VS Code. We will be doing it with pull request, Azure DevOps, with YAML script. In our past class, we have already initiated something from the pull request perspective, where we have the build and then we have installed the SFCLI. So in this class, we will see how it will happen. If I recap, let me give you, okay. So it's like first it will be pool, right? Pool means the VM image part will happen. Okay. VM image, and then we'll have the dependency part installation, that is our SFCLI, right? In this case, also known as Salesforce CLI. Okay. So once this is done, we need a delta, right? We need to store a delta as an artifact. If I recap what we did manually, here we already have the operating system, that is our local Windows application, right? And then we have installed SFCLI, Salesforce CLI, in our local system. You remember we have downloaded the Salesforce CLI libraries and then did installation. After that, we have checked the version. So that was done. And then for Delta, here we have piece of code based on our VS Code only, right? We have created a foo class, and then this is considered as a Delta. Like we tried to deploy this foo class, we did right click, and then we deployed it to the source org. But in Azure DevOps, we need to have some delta. Whatever changes we are doing, we need to store somewhere, right? Because that is not our local system. It is a cloud. So in cloud, we have this pool image, virtual image that we will create, let's say Linux or whatever, and then the installation will happen. Okay. And then based on this installation, we will have some command to generate a delta, this artifact. Once this is ready, it means we have this piece of code that we have generated. Now we want to deploy, then there will be deployment. Okay, deployment or validation, you can say. The thing that we did from the VS Code, right click and all. So these steps now we need to perform. Manually we did, now we will do it from YAML script, you can say, in pull request way. Okay, so any question as of now on this? No? So let's start. Okay, I need to rub it. Okay. Okay. So here we are doing, right? So when we see this, so we are aware about this YAML, right? So we already created a pipeline, and then we have a default YAML that time when we create a pipeline, and then we have done some scripting here. You can say like instead of that default one, we tried to write something based on the integration. And I will also explained everything like what are these in our last class. Till here we already did, right? The trigger none means so it will not trigger with any commit. So we have used this as part of uh, pull request trigger. So how we did it? So you remember we have first what we did, we created one pipeline here. Just for the recap, we created this pipeline SF build validate, right? And then in branch policies, if I go to dev, because the PR I will raise from feature to dev. So here I have used this pipeline. Now, whenever some PR will be raised for this dev branch, considering this as a target, this build will get triggered. And whatever thing is written under this YAML will get executed. So till here we have explained that okay, trigger is our for this part this is none because we have used this as a branch policies, and this will executed based on the pull request when we raise a pull request. Second is that pool, we need to define the virtual machine that we want to utilize the image, that is Ubuntu latest we have utilized it. Second is the steps. The first steps is the checkout, self checkout means we want to work with this repository. Okay. So here we can define this repository, how to check out it. Checkout means simply understand, let's say in my local system, if I want this repository, this branch available in my local system. So we used to clone it, right? The same way now here in this scenario, in this virtual machine, we need to have this code base somewhere, right? So that checkout is required. So checkout self means, so wherever this YAML is present, that repo will be checkout in the virtual machine, you can say, in the cloud. So all code base will be present, all this file will be available there. Okay. Now next is, as I said, we need to install the Salesforce CLI to start work with our Salesforce command. Then that is this installation process. Install SFDX CLI, and this is the command to install such things. npm install global SFDX CLI latest. Okay, and then this is for SFDX git delta. You remember I have said something SFDX git delta. So this is again libraries from Salesforce itself. So with the help of these libraries and command, the delta will be created. Delta means the difference between the source and target. Whatever changes we will do in this feature branch and then we raise pull request, the difference will be the delta. So that will automatically get generated based on this SFDSGit delta. The installation right now we did. And if I show you the, when we raised the pull request last time, it successfully got executed here, right? So first was checkout repository and then install SFDX CLI, that installation happened here. Okay. And then that's it. These two steps we have done this. In this, we have that Salesforce CLI installation and also SFDX Git Delta. Everything is happening here. Okay. Now Next will be after installation, our aim was to do the git delta. We need to store git delta somewhere. So this is a piece of code that we will be using. So we did till here, the installation part. Now, next bash script is for generating the delta. So this is the library that we install to utilize SFDS git delta. Now this is the command SFDS SGD source delta. You can see to head from head. It means from head means the source branch, to head means the target branch. In between, if there is any changes, that changes will be stored in build.artifact staging directory. So this is a default location for runtime in cloud. Okay. So this we have used, and this is the default command that we get from SFDS get delta. You can search it from here directly. It's not like these are the commands which are provided by Salesforce itself. Okay. So same thing I utilize here in my script. Okay. Now this is one. Second is same whatever delta is generated here. Okay. At this location based on this. Now we need to make this available in our directory. Okay. Build directory. We need to publish it. So this is the default command. This is from Azure DevOps itself. If you want to publish, the task will be publish build artifact. Okay, at that one is a version, and then display name whatever you want to put. Again, this is again the same thing. It depend on you. Now path to publish. So where do you want to publish your delta? So that we will give here. And what is the name of the delta that will get generated? So this you can put anything. So I just kept it delta package. Okay. Now I will try to utilize this code. Let's say why this is not minimizing. Okay. Now the alignment is very important here. Let me see the alignment. Yeah, it's going good. Input. Okay, fine. Now I already have this pull request is here. Okay. This pull request is already active. Now if I do any changes in this branch, okay, this the PR is already created. This is my source and target. In this branch, if I do any changes and we already have a active PR, then it will re-trigger, right? This build will re-trigger automatically because it will say, okay, new changes is there. Now the build will trigger again. So let's commit it. Okay. Now what will happen? This extra sets of code will get triggered. Now complete this YAML will be triggered. Now we have added these two tasks. So this will also get considered in my build run. So we will see here. This is pull request. Okay, it started running now. Let's open it. Now here you can see the log. Checkout repository done. Install SFDX CLI and plugin is done. So it's happening, not done. Then we have these two extra steps. Generate delta build and publish build artifact. Now if I show you generate delta build, this is the one steps that we have added, one task. And second, publish build artifact. So both we can see here. Now what will happen after this publish, I will show you where all delta will get stored. So generate means it will generate the difference. So here the difference is this foo, right? I have done these changes, foo.cls. One file changes is there in between this source and target. So let's wait. Salesforce CLI installation. So we have all documentation is present for Salesforce. Even you work for MuleSoft, the documentation you need to refer, right? How the penetration can happen to reach out with the integration. So this command I will, because that sfdx is the old one that I use right now. npm install Salesforce CLI. It's done. Oh, it's done. Let me open again. Let's. Okay. So here, check out repository, generate delta build. So please use a error null. So there is no error. It successfully. So it's saying it is stored. Now I will go back. So this is my build, right? Which got executed. Now here you can see one artifact is published here. I will open it. I provided this name delta package. If you expand, you will see this force app. The changes is in my force app foo.cls because the code base is under force app only. So whatever delta will be based on this force app folder structure that will get published there. So inside force app main default class foo.cls you can see. Now this is present here. And this package XML, you remember when I was showing manually? So package XML is important to do the validation and deployment. Whatever is present in the delta, that will be considered in the package XML. So the deployment happen based on package XML. Now let's say if I open it in this, it will be foo.cls only. Now I will give you one more example. Let's do one more class changes. That will be easy to understand. Right now only foo is the delta. Now let's have foo1 as well. Okay, foo only. Now let's have changes in foo1. Do. So for me, here will be two file that we changed. So the delta will be the difference between source and target will be these two file. Now this build is again triggered. You can see. Now let's monitor this. My expectation is now in delta two file will be there. By this we will say okay. Now we are getting proper changes detail. Now that file we want to deploy to the Salesforce org. Okay. So this concept will be same whenever you are working on any UI based application. You're working as a Salesforce resource, not Salesforce, DevOps resource. So the command and all will be different, but the concept will remain same. Whatever we explained here. Okay. Maybe based on the requirements, some different approach will be considered, but the way of thinking will be same. Like there will be some virtual machine, the self checkout will be there. Then we need to get the delta or full deployment. What will be the like this part will be same like artifacts publish you need to do. And then for the validation deployment here in Salesforce, we have different command. For other application, there will be different command to run. So that concept will remain same. Okay, it's successfully done now. Just now. If I open it, see foo cls foo1.cls. Clear? Any question till here? No? Once we are done with today's session, I expect you guys just go through with all the videos and do some hands-on. Okay. Because in our next session, I will start Jenkins because Jenkins is also one of the important tool in DevOps. Okay. So there also we will do some integration, how the integration will happen. Again, we need to take some example how the setup will be done in Jenkins, how we will communicate in between source code management system and CI/CD tool. So just to give you one example, here we are using this pipeline, right? So this pipeline is called Azure pipeline. In Jenkins, we will have Jenkins pipeline. So the work that Jenkins is doing and the work that Azure pipeline is doing is same. We, because currently we are utilizing all the feature of Azure DevOps, but when I introduce Jenkins, there I will just utilize like there as part of Azure DevOps, I will just utilize this SCM, that is our repository and branch, and for CI/CD like pipeline, I will utilize Jenkins pipeline. Okay, so that I will take in the next class. But for now, till here, if you have any queries, let me know. Next, I will just do the validation. So this is the one example for the CI/CD. Now that validation will also be done right away. Let me check. Let me close. There are many file opened. Now let's start. I'll push some more changes now. Before that, publish is done. Now next is authentication. You remember we did the authentication like here it was blank and then we tried to set the default org. And then we clicked here, it navigated to the UI page where we have provided the username password and that authentication is done. And we can see the name of that organization. Same way now before going with any code, we need to authenticate, right? Authenticate with the Salesforce or anything. So that part will be done based on this command. So again, if I explain this command, this is a bash script. Okay. So this part will remain same till here. If you are trying to execute any command in bash script, or let's say this command line, okay, the command line script will be executed in bash also or PowerShell, whatever you utilize. Here I have to bash script. So till here everything will be same till here. Sorry. Inline means so my script is written in line. Okay, it means I am just writing the script right away. Second option can be file path. It means let's say my script is written in some file. Let's say this is my file where my script is written, and then that location I will provide here. So currently, as I am writing my script here itself, so that's why it is inline. This authentication part. Now let's do it. Then SFDX auth. Let me use this command here. So this is the latest npm install Salesforce CLI. So again, here it is SFDX CLI, right? So there is some upgrade from Salesforce. So they have moved from SFDX CLI to Salesforce CLI. So the work is same, both are the libraries, but SFDX is the old library and the latest one is this one. If I write G, it will be the global part. I think it will work. Let's do the commit. Now here automatically it will get triggered. You can see I just committed something into the source branch. So we can see this message. Automatically this build will get triggered. Let's open. Look, try to understand the concept of DevOps. Okay. Again, I am saying environment can be anything, right? Java, Salesforce, .NET, Mule, whatever. The approach you need to understand. Like you need to think in this way as a DevOps engineer. Like this is the task. Now how we will take the approach. The configuration that we did, the pipeline creation, the branch policy setup, how build got triggered. That are the important things that you need to know. It takes some time to install. I think latest one is taking some extra time. How much took with the other? It takes 58 seconds. So the authentication will happen. So I have my own user, right? This is my user. Done. So authentication as I already successfully done. You can say authorized Manish Kumar as a developer with org ID. This authentication is successfully. Okay, it will end in 10 minutes. Anyway, I will share another link quickly. Okay. Ravi was traveling, that's why. Now I will quickly do the validation. You will see now something here when I do the validation. Okay, these are extra step I don't want to utilize. Install SFCLI. So I already took the latest one. I will skip this part. Okay, this one. Now this is the final step. We have done the authentication. Now we want the validation that we did from. I can explain you quickly. Okay, this is bash script, display name, validation SF this can be anything, input, target type, inline. Now this is my script. So this is a default script from Salesforce if you want to validate anything. SF project deploy. It means this is a Salesforce project. Okay. Force app folder structure. That's why it's Salesforce project. I want to validate the code and we have this manifest file, right? The artifacts is at this location. Build dot artifact staging directory and this package.xml. I have shown you, right, that there is a package XML created, and here I have done the publish. The same location I provided it here, and then test level. So to do the validation, the classes trigger is required. This is from Salesforce itself. So I have provided this test level. Okay. Now, as I have, okay, let me commit. This is committed. Now I have done some commit. It will show it here, and then if you open view to checks, you will see this. Click on the status. You can see it is now queued. The installation is started. Now we have extra steps, that is validation SF org. Okay. Now if I close this too, this is my, here if you write deployment status, so here you will get the status. So today 16/6. Okay, we already did some deployment 3:31 a.m. Now we will wait for this pipeline. Okay, we want our code, that is foo and foo1, to be validated. If there is any issue with my code, then it will fail. If there is no issue, it will success. So this is the expectation. If it is success or failure, both we will see here. Okay. With today's day, there is only one entry, so any new entry will be from our pipeline. Anyway, we can have the IDs and all. Recording is happening, right? You can see this is the steps that we can see in the pipeline. Now these steps, if I have used Jenkins, then this all steps we can see in Jenkins pipeline. So there also it is pipeline only. In Jenkins, we used to do the pipeline creation, and accordingly the integration will happen with Azure DevOps. And again, whatever steps you want to execute, that will step like this only. So the UI will be different, but the work is same. There are some other feature we can find in the Jenkins, which we can also find in the Azure DevOps. But again, this is all the choice. What all tool you are utilizing based on your project. The decisions comes from client, stakeholders and all, based on the budget and all, how they want. Successful invalidation. Okay, look, we have some error. No source backend component present in the package. So look, this is the error message. Now, this error message, I will not say like as a DevOps engineer, you need to solve it. Now, as a DevOps engineer, you have done what need to be done. So you have provided the complete setup for code validation and deployment. So here I did for validation, code validation. Now developer job is to write code and raise a pull request, and automatically these steps will be triggered. And based on the result, they will check, okay, this is the error. Accordingly, they need to fix the code. Now, whatever change is required in the code, like their code is not proper. So here I will show what, because for now, just for a testing, I created this file. So I know like this is the changes, this is changes required, and this is not right as per the development process. So that fix I will do, and then I will retrigger it. Okay. Maybe I will push the changes. So what is the issue here is, you remember apart from foo.cls, there should be meta XML file. If I open it, see here. That's why it's saying no source backend component present in the package. no source backed, sorry, backed component present in the package. So that meta XML file, due to that miss, it is failing the validation. Okay. So I will just add that file and it will start working. So here, now let me abandon this PR so that I will show you how to work from the start. I'll quickly edit. It's only 3 minutes remaining. In foo and foo1 I did the changes, right? I'll just take the name. This is my content. What was the name? Foo.cls and meta.xml. Meta.xml. Right? Create the content I will paste here. The same way now I need to create foo1. Foo1.cls meta.xml. Correct? Create. Commit. Quickly let me raise a PR and then I will schedule one call. SF validation. Okay. So there are lots of file changes. That changes we can see directly here, delta. Create it. Now this will get triggered. Okay.